Hello folks. I took my experience from over 25 years of experimenting with no tail rotors and electric tail rotor motors, which I coined ETRMs way back then. You're seeing a few shots from the experiments I did to prove my now patented NOTAR theory, along with some of my single rotor blade experiments that even surprised me. And that's what inspired us to make the T.A.D.P.O.L.E. Taking my original Hyperfly invention and design and adding a single rotor blade to the no-tail rotor feature, Bud Parriott was able to fabricate and design a body around it for super drone expansion. It's called the T.A.D.P.O.L.E. It's modular, uses only 2 servos, it's lightweight, inexpensive, and very easy to maintain. It's also easy to fly. These shots are of the first flight tests. Here you see I started with the brushed motor and speed control and not enough power. I've since switched to a brushless motor with a digital speed control. You know, also the tail plate is clear Lexan. The entire body can be made light and very stealth by using clear Lexan. And the optional nose extension is for camera equipment, a bigger battery, radar, explosives. Okay, this is the nose compartment with the camera equipment and battery. You can see in there we have spacious amount of room to put all kinds of things in here on a long version. It's a simple matter to just put on the module, battery module, just like this, or anything else that you want in there. Good to go. Note, this NOTAR can actually hover and take off almost vertically in only 7-mile-an-hour wind. And you'll note only 3 channels are required to fly these types of machines. The tail could be pulled off, throw the whole thing in a suitcase. Real rugged. You know, when hovering or going real slow, the nose is just going to automatically point into the wind like a weather vane and maintain. And it's kind of like that orientation mode on my quadcopters. Well, you see, the longer the tail boom, the less wind is needed to hover, and actually would be really perfect for short takeoff on aircraft carriers or any small ships.
This will be the hand launch.
Note the wheels are optional, and we're only using a simple Bell-Hiller head control with only a 3-channel radio. This keeps the expenses way down. It's a real reliable system. It fly really good. It's not for aerobatics or anything, but it's like a flying tank.
Here we go.
Well, the single rotor blade actually needs less power to run, and there's no secondary blade-induced turbulence, so it's pretty smooth. Although this is kind of noisy because it's an antique Bell-Hiller setup, so it could be made pretty inexpensively. Of course, it could be made more efficient too, but would cost a little more. The beeping you hear is me trimming the transmitter. Once I get it trimmed out, it's pretty smooth. But it's not doing bad for its maiden flight. And as you can see the STOL testing here, I demonstrate how good it has ability to maintain direction on a downwind leg. See, I'm pulling up in full pulses here, and you can see it still maintains heading, doesn't stall. Right turns on helicopters usually require a harder and more push on the tail rotor pedals due to being against the rotor torque. It takes less in left turns though, and of course vice versa in opposite spinning rotor blades. But you can see the T.A.D.P.O.L.E turns right easily with no tail rotor. To make sharp torque turns, you can implement throttle jockeying. Well, since we designed the T.A.D.P.O.L.E for slow orbiting flights way up high, a single blade is quieter and less visible also. And no, it will not 3D, guys, but if you want to see a single rotor blade 3D, Adrian took my idea and did that. You can watch that. I'll put the link to that amazing video in the description box. I could have put a better camera in, but I just stuck this $29 stick camera in for the first flights. And the noisy gear train is for my well-used Hyperfly, which you can search my channel to see the many videos I made on them. It's easy to land because when you reduce the throttle, the torque goes away and it just flies right in. Well, thanks a lot for the inspiration for this, Bud, and also for the great body fabrication I know you spent so much time modeling and figuring out. Great job. Thanks again. Now let's load it up with something and go fly.